Right. I can start, right?
Good morning. Good morning, and welcome to the, I think it's the 10th virtual event put on by Denver ISSA. And my name is Teresa DeGroat. I am the Director of Membership here at Denver ISSA. And I wanted to point out that these are still ongoing, lots of opportunities to earn your CPEs. We've got events now scheduled still until the end of June. So be sure to check out the Denver ISSA events page to make sure that you are seeing all the wonderful content that's available to you. So I'm really proud to present a practical approach to application security assessment. Our speaker today is Zechariah Oluk-Akinpulu, and Zechariah is a seasoned software developer and cybersecurity professional. He has a wealth of experience in information security, governance, information technology, information security program development, risk management, security incident management, threat hunting, IT governance, and IS compliance, IS control, pretty much the full gamut of security roles, as well as digital forensics, application security, vulnerability management. He has years of experience across fintech, technology companies, and the financial sector. He has delivered several topics on application security in various conferences and workshops across Africa, Europe, and the United States. And so, Zechariah, I will now turn this over to you so we can get started. Thank you so much.
All right. Thank you for the introduction. So my name again is Zechariah Akinpelu. So the topic today that we are going to discuss on is practical approach to application security assessment. I'm going to be focused more on the injection exploitation, XSS exploitation, command injection, SSI injection, code injection, and web shell attack. I will have covered the entire topic, but because of our time, and for us to be able to do a thorough job, we will rather focus on few of the exploitation which are stated on this screen. So the objective is just to make sure that at the end of the course, the participant should be able to understand the various security issues on application, not just identifying those security issues, but also on how to carry out an exploitation. And then the participant should be able to carry out a demonstration on an exploit, because as an application security analyst, you should be able to know how an exploit can be carried out by a malicious person. So with that, you'll be able to erase every false positive, because our role goes beyond just vulnerability scanning. So the participant at the end of the course, the participant will be able to understand different kind of XSS payload and also know how to build the mechanism to counter the attacks. So the participant will leverage on different vulnerabilities like SSS, vulnerabilities to carry out different tasks. For example, how to steal user session cookie, how to deface a web application, advanced phishing attacks, filter elevation, and a lot more. So we also talk about more on the command injection, web shell attack. So when I'm talking about application security assessment, to me, I see security assessment like for you to conduct a security assessment, you need to put on the role, you need to put on the hat of an hacker. And for you to take like an hacker, that means that you must be able to carry out a penetration testing. And different approach to penetration testing. You can use the white box method or black box, or a combination of partial combination of white box and black box, which is gray box. So for the white box attacks, so that means that the organization will provide you with all the information that will be required for you to carry out that assessment on the application. But for the black box, so that means that you don't have the knowledge of the application, you will be required to carry out a penetration testing without knowing anything about the application you want to target. But for the gray box, so gray box, the organization may provide you with some of the information like application design, architecture, software requirements, and all of that. So when I'm talking of application security assessment, is a process of finding a bug, and another name for bug is vulnerability. Not just finding out a bug, because if you find a bug on an application, especially the vulnerability can be false positive. So for you to carry out a thorough assessment, you must be able to erase every form of false positive by carrying out a simulated attack. You need to put on the role, the art of an hacker. And then you must also understand the technical details of the application. You must understand the technology. You must understand the way the application works. You must understand the application workflow. And for this approach, there are different approaches to this. We can, so application vulnerability are grouped into different frames, which are listed above. On the screen, we have the input validation, authentication and authorization, session management, cryptography, configuration management, exception management. But for the scope of this our workshop today, we are going to limit that scope to input validation, though I'm going to mention other aspects and how to build a countermeasure on that. So an engineer should be able to know how to carry out an exploitation. I think I've mentioned that. And there are different frameworks that you can use. So a very good one is an OWASP. OWASP is Open Web Application Security Project. So OWASP has a lot of documentation, guide that can be leveraged on. And for you to know more about OWASP, you can go to owasp.org. So for the frame, under the first area, which is the input validation. So the input validation can come from SQL injection, command injection, can come from server-side include injection or cross-site scripting. But for the authentication and authorization, we have a different form of attack like brute force attack. We have authentication bypass. We have privilege escalation. We have authorized, unauthorized URL access. For the session management, can be session replay, can be session hijacking. And for cryptography, we have the insecure cryptographic storage. The configuration management, we have the debug. Maybe if the debug is enabled before the application is, before the application is deployed to production, developers, they normally enable debug by default. So what? By the time the application is deployed to production environment, the debug needs to be disabled. But so many times the developer, if nobody checks on what they are doing, so they might leave the debug enabled, which is a vulnerability. And that kind of vulnerability will give the attackers further information about the application. Then you also have the exception management. The error exception is very, very key. And with if the error is not managed well, you can easily, the application can disclose some further technology, the underlying technology of the application. So let's go over to the OWASP top 10 risks. So the OWASP top 10 is a risk methodology, not just vulnerability. So you can see the attacker, see the attack vectors. So before any attacker can gain over an application, what they will first of all look out for is a security weakness. And peradventure, if a control is being put in place, they will look at the adequacy of the control. They will see whether they can bypass the control and to gain access to the asset and to carry out their plan. So over the years, OWASP top 10 vulnerabilities have been evolving over the years. So with some slight changes, I just displayed the changes between OWASP top 10 2013 and OWASP top 10 2017. So this is a very good resource that can be leveraged on whenever you are carrying out your assessment. And for you to get more, they have a lot of documentation on the Application Security Verification Standard, ESV. So if you go to OWASP.org, so if you are able to digest the documentation and understand each of those vulnerabilities and how to carry out an exploitation on each of those vulnerabilities, you'll be able to carry out a thorough application security assessment. So let's start with the injection. Testing for injection. So for you to test for injection, whenever you are carrying out your test, you need to put on the hat of an attacker. You need to think like an hacker. So just like an hacker, we exploit any application. They first of all try as much as possible to do an information gathering or reconnaissance. And most of the entry points for SQL injection can be through the site, web pages, URL bar, web form input values, public APIs, and lots more. So how do you identify SQL injectable entry point in the HTTP request? So SQL means structured query language, and how do you, let me just quickly explain these vulnerabilities. SQL injections enables an attacker to inject the application with an SQL payload. And if you're able to load an application with an SQL payload, you all know what an SQL does. SQL, you need the SQL to interact with the database. So that means that from the pages of the application, from the get parameter, from the post parameter, you'll be able to write an SQL statement. So that means that you are turning your application to an SQL editor, and you'll be able to query the database and do a lot more depending on what kind of information that they are looking at for. So a very good tool that can be used to automate your SQL injection payload is a Bob suite or browser tools. A browser modification extensions such as Tamper Data. We can use a web developer to view and modify HTTP requests and entry points. So on my screen, I just did a screenshot of a Bob suite. A Bob suite is free. The community edition is free, and you can use it for a whole lot of stuff. I use community edition personally, but as an organization, you can also get the enterprise or the professional edition. So let's look. I mentioned that a browser can be a very good example, but it be a very good resource for you to carry out an SQL injection payload. So for the sake of this demonstration, I have created a lab. So this lab are public available. You can download it you can download the lab on the internet, and I will also be referring to some applications that are being used for educational purpose. And some of the stuff that we are going to be demonstrating here, if you are not authorized to do that, don't do it on anybody's application unless you are authorized to carry out this kind of assessment. But for you to practice on your own, so the lab are available online. So I will mention those labs. So I make use of, there is a popular application called Automocha banking application. So you can go to the internet and just type Automocha. you see it's automutual.com. You see the application. So the application is developed for educational purpose. So you can work with that. So make use of OWASP's Broken Web Application Project. OWASP Broken Web Application Project. You can find the resources at owaps.org. And I also make use of Buggy Web Application. So you can also see that online. And then the resource I use my browser. And for the purpose of this class, I try as much as possible to try some of these things manually. My demonstration will be more of manual demonstration, and but we can always automate what you want to do. But first and foremost, you must understand how to carry out this exploit manually before you be able to automate the exploit. So the challenge number one, I'm going to switch over to automutual.com. Automutual.com is this is a banking application, and I'm just a developer. Sorry, I'm just an executive hacker, and I don't know much about this banking application. I don't have the username and I don't have the password. First and foremost, I will try different means to see whether I will be able to see where the ejection point is. For example, if I just type in something gibberish, type anything on the password page. Let me see whether I can. You can see that I have no clue about what this guy is. Let me just type any username and password. I'm just trying my luck whether I can log on. So it's telling me that this username and password was not found in our system. So for me to be able to log on to this application, username and password, that means that there will be a table that will have the username and password. So that means that for me to be able to access this application, I must be able to select that table. That means that there may be a column called username, password, where maybe username field and password field matches. So in SQL statement, an inverted comma can be used to enclose, if you want to enclose a string. I just presume that, okay, I'm enclosing an empty string. And there is a statement called Boolean statement. Example of Boolean statement, I can use or. I want to select. I want to allow the application to think that I'm writing a Boolean SQL statement. I'll just say or 1 is equal to 1. 1 will always be equal to 1, right? But this, I put, if you look at my screen, I put dash dash. So the dash dash, you use the dash dash to comment out an application, maybe a statement. So I want to comment out the password field. So anything I type on the password, just click on log on. I've been able to take over the admin, take over the application. I'll be able to log on as an admin user. So if I can log on as an admin user, so that means that I've taken over the application. I can now begin my exploitation, do a lot of stuff. So let me go back to my slide while I explain this to you. So I was able to trick the application to think that I'm an admin. So the reason I was able to do that, because most of the time, if most of the time the first feed in the database is may always be the admin user. So I'm just getting lucky that the first feed is an admin user. So that's why I was able to log on as an administrator. So let's go to the next challenge. The next challenge, I'll be doing that demonstration with a web goat. A web goat comes with OWASP broken web application. So let me go to so before this class, let me show you the lab. On my lab, I have a Kali Linux, I have OWASP broken web, and I have Bbox, which is a buggy web application. So the broken web application lab, the lab was on Ubuntu Linux. So under this, I have a couple of vulnerable applications that can play with. One of the most common one is the OWASP web goat. So let me open the OWASP web goat. So the first challenge, I just want to be sure how do I test for SQL injection on this application? Let me just type anything. Let me see. If you look at this, if you don't like put an inverted comma, it's telling me that unexpected end of command in statement, select answer from user. You can see that it's telling me an idea. So if an application is revealing the underlying technology of a database, so that's a proof that the application may be exploitable to SQL injection. So you can see that from here, I can even see more. The application is even telling me that there is a column called user underscore data, and there is a field called last name, right? So I've been so much inquisitive to, let me just type the right, let me just type Smith. Let's presume that let's presume that I'm given access to access Smith user, but I want to see the entire credit card number for all the users on that particular table. So, but I only know that there's a user called Smith based on what they've told us. So let me just enclose this string. Let me instruct the application that. So my SQL statement will look like this: select answer from user underscore data, where last name is equal to Smith. So now let me write a Boolean statement. Let me just say or 1 is equal to 1. 1 will always be equal to 1, right? Let me just say dash dash. Let me click on go. You can see that I've been able to force the application to display all the users, all the details of the users on that particular column, on that particular table called user underscore data. So if I'm a bad guy, what I will just do, I will just copy out this information. I will dump it somewhere. And to continue my work, I will. So that means that I can do more. I can write an update statement. I can update the database with my own record. I can even create a backdoor if I want to, and later come in at will. So let's go back to our slide. So that's the challenge number 2. Now let's look at the challenge number 3. We are going to use another application called OWASP Break. So what we want to do, there's another way by which you can test for SQL injection apart from you looking at the error that is being displayed if you enter the gibberish parameters. So you can also see whether the mathematical functions will work on that application. So let's try quickly demonstrate this. Let me go back to my OWASP Broken Web application. Let me open OWASP Break. Okay. I'm trying to look for the injection, the injection point on the application where I can possibly inject the application. Okay, let me go to the content page 1. So let me see, this is a get parameter. Let me see whether I can play around with the get parameter. I think I can play around with that. Okay. Let me see whether the parameters even allow mathematical function. 3 minus 2 should give me a user ID 1, right? Let's try this. You can see that. So that's a possibility that this application is vulnerable to SQL injection. Let me even try 3 multiplied by 3. 3 multiplied by 3, sorry, minus 7. Let me try that. You can see that 3 multiplied by 3, that's 9, minus 7, that's 2. So then that this application is vulnerable to, actually the get parameter is vulnerable to SQL injection. Let me even try, okay. I think ASCII one is 49, I guess. Let me try a function ASCII 1 minus 47. You can see that. Okay, I think ASCII 1 is 49. So you can see that this application is vulnerable to SQL injection. So let's try more. I want to determine the number of column application have. I don't have an idea on that particular. Let me just say I'm typing a Boolean statement. You can see that I'm beginning to write my SQL statement. I just say id is equal to the original select null. If you look at this, if you look at the error message, from the error message, I can deduce that the application is database is my SQL, and it's even revealing more. So that means that if I say select null, so that means that we have more than one column on this application, right? Let me put another null. If I keep getting the error message, there's a possibility that we have more than 2 columns. And that we have more than 3 columns. So I will just keep doing that stuff. So I can, as well as automate these tasks with my bug suite, or using any, I can write a Python scripting that will be returning. So because if I have a lot of work to do, to be waste of my time to be typing this one after the other, but you must first of all understand the idea. So let me just keep typing null. So let me add more null. made a mistake here. Okay. I want to be sure. Okay. So if you look at it, by the time I do the permutation up to 8 times, 1, 2, 3, 4, 5, 6, 7, 8. So that means that we have eight columns on this particular table called users. So if I want to do more, I can now. So that's how to gather information about a particular column, a particular user in a particular database. I can decide to do more. So let's go back to our slide. Let's look at the next challenge that we carry everybody along. So so instead of this null, I can even replace one of them with maybe something like a version. Replace. Okay. So if I want to know the particular OS, here, come here, modify this Boolean statement. I just say ID is equal to 0 and 1 is equal to 2. Just select, I want to know the details of the OS or the version number of the database. So that means that on this, I've been able to establish that this particular application is running on my SQL 5.1.41. So I can now decide to go to Google and check out the vulnerability associated with my SQL 5.1.41, the operating system that is running on with the version of the operating system is Ubuntu 12.6. So that's how you use our SQL injection to carry out for that exploitation. So let's proceed. So that's the number one vulnerability. Then another vulnerability according to WAPS is we have the broken authentication and session management. I will explain what is broken authentication and session management. We all know that HTTP protocol is a stateless protocol because when internet was designed, it was not designed with security in mind. So that's the reason why developers started using something like cookie session to keep track of the state of the application. And but if these trackers like the session are not well managed, it will leave the application to be vulnerable. Because actually with the session, if I know a particular person's session ID, and if the session is not well managed, if the application is vulnerable to session fixation, I can actually fix the session of that person to my session. So I'll be able to log on as that particular user. So session ID used to track state. Since HTTP doesn't do that. So we should be very beware of some of these common vulnerability, like remember me features. For example, if you are developing a very sensitive application like online backend application, I think OWASP recommend that remember me feature should be disabled, especially for password, for secret questions. But if it's social media, is allowed. And on their part, we all know that it's very easy for somebody to hijack somebody's username and password. So in modern days, it's always for a very sensitive application to make use of multi-factor authentication. Don't trust your username and password. And if at all you are going to trust your username and password, let the password be very complex, and make sure that you don't trust the username and password by making use of a multi-factor authentication. So user accounts can easily be compromised if the session is not well managed. So how do you test for this? For example, like that, let me go back to one of my lab and demonstrate to you. If I want to show you how, whether, for example, there's an application called OWASP multi-dilate. So if let me log on, there's my login button. Let's presume that I don't know the username and password. You can see that it's telling me that account doesn't exist. Let me do something funny. You can see that if you look at this, the error was well handled, but was not handled correctly. It's telling me that the password is incorrect. So that's a very bad design. The error should be such that username or password, invalid credentials. I should be okay with invalid credentials, not telling me that password is not correct. So that means that I can deduce that, okay, there is a username called admin, and with this, I can come up with a dictionary that has different correct username and try to brute force the password. So to make my work easier, as a bad guy, I can use a Bob suit to brute force the password if the password is not complex. Okay, so let's go back to our slide. So that's one of the ways by which you can see whether there is an application developed to broken authentication or session management. So I made mention of how to brute force. So on this page, what I did there, I used a module on Bob suite called intruder, and I use a cluster bomb to brute force, to automate the brute force, and I selected the feed that I want to brute force. If you look at this feed, on my cursor, I try to brute force the username and password, and I have a dictionary that I'm using. So when I click on start attack, it depends on to take a while, but I won't demonstrate that because of I still have some lab that I need to touch base, but I'll just explain that. So instead of you doing trial and error, you can use a Bob suit to brute force to brute force a password or to brute force a username or password. So let's go over to XSS. XSS is cross-site scripting. Is the number, I think for over the years, it has always been number 2. SQL injection is number 1. Number 1 vulnerability, followed by cross-site scripting. So how does it occur? So let me explain what is cross-site scripting is. So if an attacker can send a malicious script through the browser, or if an attacker can write a script. A script maybe might be HTML script, it might be a JavaScript, and if the application allows that script to be executed on the browser, so that means that the application is vulnerable to cross-site scripting. So Virtually, most applications are vulnerable to cross-site scripting. So let me quickly talk about how do we deal with this. So how do we eliminate cross-site scripting? Though the group user supplied input into the output, and always enabled content security policy, then you can also make use of different libraries. Libraries, trusted libraries like OWASP library, SAP, Java encoder. Also make sure that you encode every strange character, use the right character encode. Also make sure that you whitelist all the inputs of the application. For example, if I'm supposed to enter my credit card number, a feed on the feed, the application should be developed in such a way that I will not be able to write anything except numbers. So I'm going to do some demonstration how to carry out a test on the cross-site scripting. So we'll call it XSS. So how do you do that? You just like the way you look for SQL injection payload, you can look at different parameters, look at the post parameters, look at the get parameters, see whether you can inject your SQL, sorry, your XSS payload. Let me go over to atoromutual.com. Okay, so let me just play with this search button, the search feed. Let me just type something like book. Let me click on go. I just want to see how this thing look. Now let me write an HTML tag. Let me see whether the HTML tag will be rendered. If the HTML tag is rendered, that means that that particular feed is vulnerable to XSS. So you can see that it's really, it actually rendered the stuff. Let me even use one of the title tag. Go. Right. This particular feed is vulnerable to XSS. Let me write a script. Let me write a JavaScript. Let me just write a simple alert JavaScript. Who. Is taken. You can see the JavaScript. I was able to execute a JavaScript on the pages of the application. So that this application is vulnerable to SQL injection. Sorry, it's vulnerable to XSS. So we have different types of XSS. We have the reflective XSS, and we have the stored XSS. Both XSS are dangerous, but stored XSS is more dangerous. A stored XSS store the payload on the web server, while a reflective XSS, the payload will only be reflected on the browser. So let's proceed further with our slide. So on this target application, you can see I'm also testing for user agents, whether the user agent is vulnerable using my Bob suit. I can also use Bob suit to manipulate my injection. So let's just do some couple of lab on different types of XSS. I think I've demonstrated this. Let me just do something more interesting. Okay, so what I want to do here, I can actually use an XSS to steal the cookie. I can use it to steal the cookie or the session ID of an application. Let's say document. Let me just say alert. Alert document cookie. see, this is the session ID for this particular admin user. So with an application that is vulnerable to XSS, I can see somebody else's session, I can see somebody else's cookie. I can so if the application is vulnerable to session fixation, I can actually copy this cookie, or I can, if this application is vulnerable to store XSS, I first of all write my payload. I will direct the payload in such a way that the cookie will be sent to my server, maybe another server somewhere. I can save it as a text message. So for everybody that log on to that particular application, I will be able to have their session ID. So later on my spare time, I can now decide to see which of the session IDs is more interesting to me. So that's what you can do with that. So let's go over to the next slide. Let me do a demonstration on how to use a store XSS to carry out a very dangerous attack, and how to use a store XSS to actually listen. Let's presume that an application is vulnerable to store XSS. What I want to do, I want to be listening to the application remotely. Maybe if anybody log onto the application on my console. So I have a two lab that I'm going to display here. My number one lab is Linux. Let me, okay. I hope my screen is, let me confirm the IP address for my Kali Linux. Okay, the IP is 40.128. So before I do that, there's another lab called the buggy web application. I want to, let me reset this first. Be sure. Let me log on. Okay. So I want to monitor what is going on here. This is the attacker machine, right? I want to monitor what is going on here. Let me, okay. I want to use a netcat to listen to what is going on that, on the other machine. So let me just start the listening. I think I've written one simple script, HTML script. Okay, let me inject this application. Sorry, where's my lab? Let me inject this application. So this IP address of the attacking machine. And I've set up a listening on port 112, right? So let me go back to my attacking machine. Sorry, let me restart this guy. Let me show this IP. Okay, it's 40.128, right? Okay. If you look at this, you can see that this is the header of the application. Sorry, this is the header of this particular the script that I just wrote. So I'll be able to capture, listen to what is happening. So let me do something more interesting. So let me just do something. Let me trick a user to, I want to trick a user to enter the username and password, right? Let me start this thing all over again. Let's do this. Let me trick the user. I want to write a statement that will allow a user to enter, that will redirect the user to another first page where they will enter their username and password instead of this gibberish blah blah. Let me just do this. If you look at my statement, if you look at the post parameter, the action, it will redirect the user to the attacker. This is attacker mention, right? And I just instruct the application to enter username and password. That's all. So you can see that immediately use this application, they won't be seeing the real page. They will be saying, I fake the application to tell the user that the session has expired. So let me just type in or try to log on. So the user will just be wondering what is happening with this application. Let me do this. Let me come back to my listening ports. I'm coming. Let me try this listening again. This dot 128. Let me reset. I have a fresh page. Okay, I've not started my list now. Let me start the list now here. So what I'm trying to do, I'm trying to listen to the application from my attacker system. Yes, 154. Okay. Now what's wrong with the lab? We need to reset this lab. So what I'm trying to do, I started listening. Let me explain the process again. I started listener on the attacker machine. I asked the listener to be listening on port 1122. And at the end of the day, I entered that so whenever anybody log on to that fake page that I've created here, so my listener will be listening to the username and password. So that's what I'm much more interested on. So from my attacker machine, I'll be able to see the username and password. So we'll try over again. Let me reset. I will need to reset this lab. So let me reset the lab. I will come over this again. Everything. So let me set everything. And let's try the next. We come over it again. Let's try. Do we have different type of injection? As I've said, we have a SQL injection. We have a command injection. XSS is a form of injection, right? So I want to the application. Maybe I want to see whether an application is vulnerable to command injection. So let me go to one of these one of the setup here. Let me start something on the command injection hack. So what this application does, this application helped me to do a DNS lookup of nsa.gov, or I can put any website. Just do a DNS lookup on it. So you know that DNS lookup, this kind of application, that is more or less like kind of it allows. It's possible for me to be able to inject the application with command line. So let me just put this simple command lookup. Let me try one of these commands. Let's see what happens. Before we try the command, let's first of all set up our listener. Let me set up my listener here. let me set up my listener here. This time around, let me just do, okay, let me listen on the port 44. Let's just say 4444. Why I've set up my listener, so let me just see whether I can inject the application with some funny command. Let's try this command. Application. Okay, so let me explain this command. What I'm trying to do here, this is an attacker. This is an attacker IP address. Let's be sure of the IP, but that has changed. Okay, still remain that. If you look at this, you can see that by listening, it's actually listening. It picks up the application IP. Let me be sure that is the application IP. Where is my command line for this application? Okay. You can see that my listener is actually listening to the application. So I've been able to establish, let me explain this command again. So I've been able to establish a shell. So what this command does, it gives me a shell of this application. It gives me the shell for this application on port 444. So let's see whether we can, let's try and see the parent working directory, pwd. So you can see that the parent working directory is on my buggy web application. So let me do something more interesting. I can do an ls. Let me do something. So you can see that from the attacker machine, I've been able to take over the shell of the application. So let me do something much interesting, because as a bad guy, I might be more interested in something. Let me just say PSW, right. Okay, sorry, let me just do to PTC first. Start PSW, right. Let me change directly to etc. Do a cut of, if I want to see the web.config file, web.config. So this is the web.config file of the application. So you can see that I've taken over the server of the application using a command line injection. So that's how vulnerable an injection can be, especially the command line injection. So you can use it to establish shell on the attacking application. What you just need to do, let me explain the process all over again. Let me go back to my slide. I establish a listening port on port 4444 on my attacking machine, which is my Kali Linux. I now append the IP by adding. So I append it by typing this netcat command. This netcat command will help me to establish a shell on the attacking machine. So immediately I do that, I was able to establish a shell. Establish a shell means that I was able to gain access to the operating system of that particular machine, the command line of that particular machine. Very dangerous vulnerability. So that's how to carry out a command line injection vulnerability. So let's also try another. You can also do a reverse injection, which is for the blind. For example, now, well, for this application, me looking at this application, I can really the application is vulnerable to SQL, to command injection. So let's try something a little bit different but similar. Okay, let me reset this guy. Reset first. Let me close this and start all over again. I just type a bug. Let's try something a little bit different for Eversense. So let me see whether I can ping myself. This is an application that you can use to ping an IP address. I think my IP is this, right? Okay, let me do this. Let's do this. I want to establish another form of shell again. Okay, I have no clue whether this guy is vulnerable, but let's try this to this bash, right? Let me append this. Hold on. Let me come back here. Let me terminate this session, this listening. Let me clear the screen so that it will not look untidy. Okay. So you can see, I've been able to establish a shell. Again, excuse me. I'm able to do an inverse shell on the attacking machine. I think shadow is I can let me look at my parent working directory. Sorry. That's how to establish a shell using a command injection. So let's go back to, excuse me, please. Let's go over to our slide. So I'll be able to explain the different type of injection from the store XSS to command injection. And let's try another form of injection, which is a web shell or the code injection. So that's what we call the web shell. So let's try this and let's see how far we can go. Let me reset my lab, my vulnerable application lab. Let me reset so that everything will refresh. I'm using a buggy web application.
Zachariah, we're going a little over here. So okay. I was wondering if I could ask a question that one of the users had.
Okay.
Yeah.
So go ahead with questions.
Yeah, so the question is, are there any good resources for people who want to learn how to do these sorts of attacks? Because they're on a blue team. He agrees with your comment that the blue teams need to be able to attack. And so he's wondering if there are good resources to get started on how to learn how to do this.
Okay, so let me rephrase the question. So that is there any good, how do you get a good resource to carry out this form of? Can you repeat the question, please?
Yes, any good resources to get started on learning how to do these kinds of attacks?
Okay, good resource. Okay, that's a very good question. So during the course of the presentation, I made mention of OWASP. OWASP.org is a very good resource. And for you to really conduct a application security assessment, you must understand the basic of the application, of the application, the underlying technology of the application. So you can learn the basis of SQL statement. If you want to be able to write a very dangerous SQL injection payload, you must understand how to write an SQL statement. You must understand some little bit of programming language. You can learn something from w3schools.com. You can also go to owaps.org. Everything that you need about on the web application, their standard and all of that, you can learn it from owaps.org, or you can also enroll for like what we are doing today. Today is more like a kind of a lightning session, so that because for you to be able to do this, you must be able to ready to get your hand dirty. Probably if you can write some code. It's easier for me because I started as a software developer, and before I put on the security hat, but you don't need to, I'm just teaching the basis. You just need to understand the basis, SQL, statement, HTML, the base of JavaScript, and all of that. I don't know whether I've answered the question.
Yeah, I think it did. People are, if you need to leave, you can leave. But Zachariah, how much longer do you think you will be?
What is it? Okay, there are more time. Maybe in the next 10 minutes, I should be able to finish up.
Okay, sounds great. Thanks.
All right. So you can learn more on owaps.org. On owaps.org, there are a lot of resources, a lot of lab that you can play with. There are tutorials that you can start with, and you can learn from. You can learn some basics of HTML and all of that. So let's go back to our slide. Okay, I think the last, I'm mentioning something on code injection, which is a web shell. How do you conduct a web shell? I think I'm trying to reset my lab before that question pops up. Let me go back to my lab. Okay, let me go to PHP injection, and click on this. So I want to see whether I can actually inject the URL, the get parameters, with some funny code. Let me try with the PHP info. PHP info is a function that displays the details about your PHP server, especially your Apache server. Let me see whether I can run this. You can see that instead of it to just type normal text, I just do a semicolon. Use a semicolon to end a statement. You can see that I'll be able to see the details of the underlying technology. This application is written with PHP 5.2.4 and it's running on Ubuntu. It's telling me about the Apache. It's telling me about the configuration file. This is a very dangerous information that I'm looking at. So all the configuration, the server configuration, I can see it, which is very, very dangerous. So you can see that this application is very vulnerable. So I can actually write a code and on the get parameters, and I'll be able to execute that code. So let me do something more interesting. Let me just do something much more interesting. Let me try and see if I can establish a shell to the application, right? Okay, I will explain what I'm doing. So this is functions. There's a function called system. Use this function to load in your shell, your shell into the PHP environment. So I'm loading I want to listen on port 123, right? I'm listening on port 123. It's going on. Let me go back to my listener. I don't know, have I set up the listener? Okay, let me go back to my listener. See whether I can listen to this application using this. Okay, let me close this. Okay, this is my web application. This bbox, the IP address is 192.168.40.154. So I've already established a listener here. I'm doing a reverse share this time around. So let's see. You can see that I've been able to establish a connection. I can actually listen. So I've established a share. And if somebody can gain a share on the application, so that means that you take over the application server. So that's a very dangerous vulnerability. So you can see how dangerous the code injection can be. Injection code is server-side include injection. But because of our time, I will just quickly explain this. This one too, you can actually use this to inject an application with a server-side include injection. So let's just quickly brush over to the end of the slide. So I said that during the beginning of the course of the lecture that I'm going to focus on on the SQL injection, XSS, command line injection, and the web shell. I'll be able to achieve that. So I'll just quickly, apart from the other, that vulnerability, we also have the vulnerability that has to do with the test for broken access control. How do you test for broken access control? For example, now, if I'm a user A, I'm not supposed to be able to access a user B functions. So if I have the URL for user B and I can access the URL user A access, so that's not right. So that's that's a good example of that. So how do you eliminate broken access control? You need to replace, eliminate direct object reference, especially on the URL. Like the application that made reference to like the brick over brick application. You can see that the URL are incremental. That is very, very dynamic, not something that is too static. So then you also to verify the parameter values. Make sure that all values are properly validated, are properly formatted, and make sure that you query don't assume. Validate, server-side validation is very, very key. If I'm a user A, I'm not supposed to access user B details. So for every user that access an application, you need to validate the proper server-side validation to establish that a particular user is supposed to access a particular resource, or supposed to access a particular function. So the zero test, because of our time, will not be able to put up, but I will just explain with my ID some screenshots on the web code. From here, you can see this is the kind of reference I'm talking about. This is the kind of reference I'm talking about. Some application has that variable to the extent that you can even see you can do a directory listing, you can do a directory force browsing, and a very good tool that can be used. There is a tool called the directory poster. So the tool can be downloaded on the OWASP.org. There are a lot of resources on OWASP.org that we can leverage. For security misconfiguration. So what is security misconfiguration? So for example, now the underlying technology of application, the OS, make sure that the OS is adequately patched to the latest patch. Make sure that the OS is well hardened. And like the couple of applications that we'll be working on, you can see that the OS, the underlying server, they are not the latest server. Even the underlying technology, imagine an application running on PHP version 5.0, that's a very old technology, and there are a lot of vulnerabilities on PHP 5.0. So that was the reason why I was able to carry out so many of those exploits that I displayed. So think of all the places your source code goes. So make sure that wherever from the production, you need to think of from the test environment. How do you upload your application to the? Most of the time, the developer normally make a mistake. The source code from the development environment should be very different from the production environment. So most of the time, because in the development environment, there are some things that are always enabled, like debugging is always enabled, and based on but whenever you are deployed to production, make sure that debugging is disabled. Those are the security misconfiguration: hardening of the server, the web server, hardening of the databases of your application. So I've talked about hardening that the automation is very useful too. Then analyze your security very, very well. So another form of vulnerability based on the OWASP top 10 is what we call the sensitive data exposure. Sensitive data such as password. Password should not be written on the database in plain text. The credit card number should not be written on the database in plain text. Like, for example, if an application is vulnerable to SQL injection, if I'm able to do a dump of a particular table, so I'm not supposed to be able to see the card the credit card number, like the one I displayed when I was doing a demonstration on SQL injection on the web code application. I was able to see the credit card information of all the users of that particular application. So sensitive data should be encrypted and should be well encrypted and should be hashed and sorted and on the database. Let's presume that application developed SQL injection. If we do a dump, I won't be able to see those such sensitive information because such sensitive information has already been hashed. So that's a countermeasure against sensitive data exposure. There are another vulnerability called as a known vulnerable component, like the library, the JavaScript library, the framework that the application makes use of. Make sure that the framework that you use, the up-to-date framework for you to guard against exploitation on your application. So all these things can be automated, and you can check this by leveraging on the library, actually the vulnerability libraries. Check the CVE and the repository to make sure that all the components that they are using, they are not vulnerable components. So we've talked about different vulnerabilities. We've talked about SQL injection, cross-site scripting, command injection, web shell, SSI injection. So how do we ensure that your application is clean and tight? First and foremost, you need to ensure that your developer develop a secure code. Just for answer the question that somebody asked. So follow the best practice in the web guide to build a secure web application. You can go through this. The URL is on my screen. They use OWASP application security verification standard as a guide to what an application needs to be secured. So you can ask your security team to leverage on the ASV, OWASP ASVS. The ASVS is very, very robust. I use it a lot, but it's another thing for you to know how to carry the exploitation. That's where the training comes into play. So there are tutorials on different kind of on different types of vulnerability and how to carry the exploitation. There are open framework that you can use. You can use web codes to simulate a vulnerable application and also see how you can hack a vulnerable application. Please, whenever you are doing this test, maybe you are doing a training, make use of the publicly available training guide. Don't carry out your assessment on an environment if you are not authorized to do that. So that's unethical. So you can create your personal lab, like what I'm doing now. I have dozens of lab that I use. I'm now also using my personal system. This system is attached to my organization. So you can download different labs and on OWASP.org and different labs. So use standard security components that are fit for your organization, depending on what works for your organization. So you can ask your developer to make use of different libraries. For example, if you want to develop an authentication and authorization module, you can use a SAP, OWASP SAP module, or anything that works best for your developers. You need to review your applications regularly. Have an expert team that review the application. Like where I work, I have the teams that normally conduct application security testing, teams that has a development background and that put on security hat, and security should not be seen as an afterthought. So that's the reason why you need to do a code review. I mentioned of code review here. So a code review helps you to identify the code, a vulnerable at the code level. Even before you even develop the code, you need to ensure that you engage the stakeholders and identify the risks that can come up on the application, and you also need to look at that. Then OWASP testing guide is one of my favorites. Apart from you doing a code review, there's a code review guide that you can use, and there are a couple of tools, dozens of tools that can do the static code review for you, or you can engage a very experienced developer that has been trained to be a security engineer to do the code review, or you can automate the process there. after doing all of this, after doing a lot of the iterative testing, after doing your SAS security assessment, static application security testing, after doing your dynamic application security testing, even when your application is on production, you need to make sure that you implement a web application firewall. For example, now, if all these applications are under the web application firewall, if I thought the application is vulnerable, I'm able to try that exploit. The web application firewall has the intelligence to see, it has intelligence to deduce if somebody is trying to inject an application with SQL injection payload, with SSS payload, with SSI payload. So that's that inbuilt intelligence built in place. So I think that's wrapping up. I don't know if you have any questions. Thank you.
Thank you, Zachariah. This was an extraordinary amount of information, and we appreciate this being available to people. If people want to get in touch with you through email or social media to ask more questions, would you be open to that?
Yeah, I'm open to that.
Okay. Well, thank you again for spending time with us today, and thank you to everybody who stuck with us for this rather long event, and we look forward to seeing you all in the future. Zachariah, stay safe. And
thank you.
Again. Bye-bye. All right. Take care. Bye-bye.
Thank you. Bye-bye.